Hello there, my name is Dominic and today I have two items that will be the biggest and heaviest thing that I have ever unboxed ever on my channel. With me here is a Deye Sun 6 kilowatt off-grid solar inverter. The other item is so heavy, even if I could lift it on this table, of which I can't, it would break this table. And that is a 5.12 kilowatt hour lithium-ion battery pack, also from Deye. So welcome to this unboxing. I'm also going to take you through the specifications of each item as I unbox it. I hope you can see that. This thing is so well packed. Look at all these corner braces for the packaging. That is the manual. The model number is SUN 6K OG01LP1 EU-AM2. The EU means that this produces 230 volts. Throughout this video, I will also give you snapshots of this user manual. I will also provide a link to this user manual in the video description below. And here is the inverter itself. Looks very nice, sleek, and modern as well. And these are the other accessories. Let me just get this box out of the way so that we can check the inverter and these accessories one by one. The front is made from plastic, but the sides and the back are made from metal, specifically aluminium, because it's not magnetic. This is a tiny magnet. Nothing is magnetic here except for this fan grill here. So let's take a look at this inverter all round. At the bottom we have the circulation fan as well as all these other connections. The battery cables will go through here. These are for your communication either from the inverter to the battery or from one inverter to another inverter, because you can actually connect these inverters in parallel to one another. The backup load cable will go through here, the generator cable as well as the grid cable. Because this is a hybrid inverter, it has solar as well as connection to the grid. This inverter also has twin MPPT, and that's why you can see it has PV1 and PV2. That's for connecting the protective earth, and that is the on-off switch. On this other side, we have this plug. It's supposed to be a DC switch, but that is optional. So there are some models that will have a DC switch here. That's the aluminium cooling heatsink. And at the bottom there, that's the small fan we saw. And here are all the specifications. You can pause and read, but I'll just go through them again in this video. That's the Wi-Fi serial number. I just had to block that, as well as other information about this inverter that I just don't want to go out into the internet. These are the other accessories. That's a network cable for connecting the inverter to the battery. This is a special spanner for solar. This is what I'm going to use to connect the cables from the solar panel to these MC4 connectors so that I can ultimately connect it to the inverter. These are the wall mounting hangers. This will be mounted on the inverter so that I can use these bolts to connect it to the wall. These are the screws for mounting the wall hangers to the inverter, And finally, we have a battery temperature sensor. I won't be using this because I have a lithium-ion battery, but this is important if you're going to connect your inverter to lead-acid batteries. All these connections are done by removing this panel. You can see this gasket all around here. This inverter has an IP65 rating. This means that you can actually install it outside. It can keep away the dust, but keep it away from direct sunshine and moisture. This might look overwhelming at first, but it's quite easy. The most important, the battery connections. You can even see the polarity here, positive and negative, also molded into the plastic there, positive and negative. That's where you connect your backup load, generator, and to the grid. One very interesting thing to note about this inverter is that it can actually switch on your generator, and that's by using these ports here. Now I will explain all this together with all these Ethernet ports here after I unbox the battery so that I can show you how the connections are done. Like I said at the beginning of the video, this is a 5.12 kilowatt hour battery. It's quite big. Let's see what's inside the box. First thing is a template for drilling into the wall. That is the user manual. We even have a sticker. Again, this thing is so well packed. Look at that rigid foam padding. These are the cables. I can see a black cable for the negative terminal and a positive as well as a protective earth cable. Quite a number of accessories behind here. I believe that's everything. The battery pack itself. It's again so heavy. It has handles here. It was so well packed. Look at that padding on the sides. And this is the 5.12 kilowatt hour battery. You do notice that this battery does not have a breaker. That's why I bought a breaker to install it in between the inverter and the battery. Let's take a look at these ports. These are the battery terminals for the negative and positive terminal. These are the notification lights for state of charge, the alarm as well as the run light. And here are all the communication ports as well as the power button. This PCS port is what is supposed to be connected to the inverter directly, to this port here labeled as BMS or Battery Management System. The other ports are for connecting the batteries together. You can actually install these batteries in parallel to one another. For example, I could have two batteries connected to this single inverter, and when I do that, the PCS will be connected to the inverter. The output from this battery will be connected to the input of the next battery. I hope that is clear. And when you add more batteries, you just go on connecting them like that. You can actually connect up to 32 pieces of battery. Same case with the inverter. You can actually connect this inverter in parallel with other units to increase the power output of your solar installation. Let's take a look at all the accessories that came with the battery. These are 4-gauge battery cables, 1 meter in length. Next, we have a 10-gauge protective earth cable, an Ethernet cable, also 1 meter. hooks for mounting the battery on the wall, V brackets. Now these are for connecting the batteries stacked one on top of each other. You drill the holes on the wall using this template. You mount this on the wall and then you lift and rest the battery on these brackets. With this placed, you can just place another battery just like this one on top of the other battery. And that's where this sticker comes into play, because when you block this sticker, you can actually use the provided sticker on the front just like that. These are the screws for the V brackets. And finally, we have the bolts for mounting the battery to the wall. It seems overwhelming at first, but it's quite easy when you understand what you're doing. First of all, we have the battery connection here. The polarity is well printed on the plastic piece here. Next, we have these orange connectors here where you connect your backup loads, your generator, and to the grid. The two that I'm going to use are, I will connect this inverter to the grid and also to my backup load. I do not have a generator that I will connect here. And it's very easy to connect. You just insert your cables there and you press this. They are usually very strong, even better than the ones with screws. Now, let's talk about the communication ports. The first one here, that's for energy meter communication. The second one is Modbus, that is reserved. For most applications, you will never use this. Now, these two ports are for parallel communication ports. They are also labeled there. If you connect this inverter in parallel with other inverters of the same model, you are going to connect these inverters together using these two ports. And the most important one that I will also use is this one here, labeled as BMS CAN. Now, this is for battery communication. What I will do is that I will get my cable and insert it there, and the other side will go into the battery where it's labeled as PCS, like that. As you can see, that's very easy. And finally, I cannot wait to connect this inverter to the Wi-Fi so that I can see all the statistics. It's very nice that it has an internal Wi-Fi module. This is a glimpse into the future. I have already installed the inverter and the battery. I just want to show you the functions of the function port. Labeled from the left, ports 1, 2, 3, and 4 are for connecting the generator. This inverter has the ability to turn on a generator, and if you do that, the output, you will connect it to the generator port like we saw earlier. Number 5 and 6 are for connecting a battery temperature sensor, and this is if you are using lead acid batteries. I do not need to use this because my inverter and my lithium battery have a communication between them, so I do not need to use this. But if you have lead acid batteries, then the inverter needs to know if they are overheating, and this is the temperature sensor for that. And finally, number 7 and 8 are for connecting a current transformer coil. This inverter didn't come with that gadget, but that is usually to track how much load you are using from your grid. You can watch this whole installation in my second video of this Deye inverter and battery series. Check the video description for that video. Another very important thing, the protective earth cable. You should always connect this cable between your battery and your inverter. The inverter connection is here and the battery connection is here. According to the inverter manual, you're supposed to connect the inverter to the battery using 50mm square cables. 50mm square is the cross-sectional area of the conductor inside, and that's what I have here. Very thick cables. I was just testing if they fit inside here. Now, also according to the manual, you're supposed to connect a 200 amp DC breaker between the inverter and the battery. And this is what I've bought. This breaker didn't come with the inverter or the battery. That's the DC breaker. The lugs have been professionally crimped. They were crimped at the shop where I bought these cables. This DC breaker also acts as an isolator, very important for isolating the battery from the inverter. Some other things that I bought are AC breakers, which also act as isolators as well. I have two of them. One of them will go from the inverter to my backup load, and the other one will be installed between my grid, which is the consumer unit, and the inverter. Together with the AC breakers, I also have this housing boxes. When I install them, they will look something similar to this. And not forgetting cable. This cable will go from my consumer unit to the inverter, and another cable will run from the inverter back to the consumer unit to my backup loads. I won't connect everything to my backup loads. I will select a few circuits, like for example the socket outlets and the lights as my backup loads. Everything else that requires heating, like the water heater in the shower and the cooker, they won't be connected to this inverter. Let us now go through all the important specifications of the inverter and the battery, and I have my notebook here with all the specifications. Like I said, this is a 6 kilowatt hybrid inverter. It uses both solar and grid and can also be connected to a generator. The inverter works with a DC voltage range of between 40 to 60 volts. My battery pack here is a 51.2 volt battery pack, so it falls in between those voltage ranges. But you can also connect lead acid batteries to this inverter. If you have 12 volt batteries, you'll have to connect 4 of them so that you can get 48 volts. The inverter has a maximum charging voltage of 135 amperes and also a maximum discharge current of 135 amperes. You can see it's very important because our breaker is way past that. It's a 200 amp DC breaker, but the maximum discharging current is 135 amperes. So whenever anything goes wrong between the inverter and the battery, if it crosses that 200 amp mark, this DC breaker is going to shut itself down automatically. The maximum solar access power is 12,000 watts and the input power is 9,600 watts. The maximum solar voltage you can connect to this inverter is 500 volts. Like I said before, this is a twin MPPT inverter. The startup voltage is 125 volts. So I'm planning to start with 3 solar panels. With an open circuit voltage of around 50 volts, I'll get around 150 volts, which is above 125 volts, which is the startup voltage. So this inverter cannot work with a single panel. Take note of that. The maximum solar input current is 18 amperes plus 18 amperes. Like I said, twin MPPT. And the rated output voltage, this is an EU model, it's 230 volts. The efficiency of this inverter is 97.6%. It weighs around 12.65 kilograms and comes with a 5-year warranty. The dimensions, which are the maximum dimensions, are 463.8 millimeters by 350 millimeters by 175.77 millimeters. And now let's talk about the battery specifications. The voltage is 51.2 volts, but the operating voltage is between 44.8 to 57.6 volts, which is less than the maximum of the inverter, which was 60 volts. Now it is a 100 Ah battery, and if we multiply those two together, we get 5.12 kilowatt hours nominal energy. The dimensions are 370 millimeters, height of 548 millimeters, and a depth of 140 millimeters. Now you can connect this unit in parallel with other units, and it has over 6,000 cycles at 80% depth of discharge. So this thing will last you years and years. You can either install it on the wall or stack mount it like we talked about earlier, and it has smart integration, meaning that it communicates with the inverter and other batteries connected in parallel. It has an IP protection of IP21, so do not install this battery outside in the elements. Also avoid places with moisture or open flames. I will also put a link to the user manual of this Deye battery in the video description below. And finally, the net weight, 41 kilograms. That's it for this video, but this is not the last time you'll be seeing this inverter and battery on my channel, because I'm going to do 2 more additional videos. The second video will be an installation video where I install this system as a backup load for my apartment. I will also do all the settings between the inverter to get to communicate with the battery, as well as other settings on the inverter. I will also do a third video where I will possibly connect this system to solar panels and see how it goes. I will also give my honest review of how I will have used this system then. Like, is it loud? Is it easy to use? How was it? Is it overheating? Is it cold? I'll answer all those questions, as well as other questions you, my viewer, might have. Post them in the comments below and I'll be sure to get to them in my 2 other videos. That's it. I hope you learned something new today. Let's meet in my other videos. and goodbye.